Hello and Namaste. My name is Mr. Gautam Mehra and today I'll be talking on post-carburizing heat treatment. So already I have talked about carburizing heat treatment on steels and today I'll be discussing on post-carburizing heat treatment and its needs. So after carburizing heat treatment, the steels are given some of the specific heat treatment so as to improve the properties by modifying the microstructure which has got altered during the process. So what happens to the steel microstructure due to carburization process? As you understand, the carburization of steels is done at a very high temperature, basically at above 900 degrees centigrade and up to 1040 degrees centigrade. So it is a very high temperature, and carburization is done for prolonged interval of time, for high exposure time, to get maximum case depth. So due to these two reasons, the grains at the core and at the case become coarser, and once the grain become coarser, we understand the hardness and the strength of the steel get reduced. And another point is, when the steel is exposed during carburization, sometimes what happen, if the concentration of carbon at the surface become very high, in that conditions the cementite networks, the carbide networks start forming on the surface, and carbide networks are brittle in nature, so it deteriorates the property of the steel. So these are the two major concerns while doing carburization. Next, different objectives of post-carburization heat treatment. So the first objective is to refine the grain size, and the second one to obtain high hardness at the surface, and the third one breaking down of these carbide networks at the case. So how we can achieve these three objectives? Can you people think of that? Okay, let me explain. To refine the coarser grain, we understand we can do something, that we will take the carburized steel to a high temperature and then we quench it. So during quenching, the cooling rate will be very fast, or you can do normalizing. It will reduce the grain size. The faster is the cooling rate, smaller is the grain size. And similarly, if the grain become finer and finer, obviously the hardness and the strength of the surface will increase. And further, how we can do breaking down of these carbide networks? It is very simple. When if you take our steel to a very high temperature, and so for some interval of time, so what will happen, the carbides are nothing but the precipitates. They start getting dissolved into the phases, austenite phase or the matrix, and on quenching we can prevent the carbide network formation also. Then post carburizing for inherently fine grained structure. Best example is any aluminum kiln. So there are certain steels which have inherently fine grained structure. So in that case, what is the post carburizing heat treatment? It is a single step heat treatment where steel is heated above AC1 temperature and just oil quenched. But the condition become different when we do post carburizing heat treatment for coarse grained steels. So in case of coarse grained steels, it consists of two steps. The first step is the steel is heated above S33 temperature and normalized so as to refine the coarser grain structure. And the second step, steel is heated above AC1 temperature and quenching is done. So grain in case get refined and get hardened, and this hardness of the case is due to quenching as well as due to the transformation of austenite to martensite. Now, advantage obtained on heating to high temperature and quenching the steel during post-carburization heat treatment. It is very simple. Already I have discussed that on heating to high temperature above 750, the carbide networks dissolves and quenching, and on quenching they will not appear again. Now I will discuss a procedure which have already been developed so as to get maximum case hardness with very fine grain case and co. So it includes 4 different steps. So you understand, this is the step which I am talking about, carburization and post carburization, which is included in this. So the first step is the steel is carburized at a very high temperature like 1040 degrees centigrade for given interval of time. Then it is oil quenched. And the next step is tempering, where the retained austenite will transform into bainite. So bainite is a very good microstructure which provides high strength, high hardness also, and good toughness also. Next, third step is the steel is rapid austenitized and oil quenched. And the final step is final tempering, where the tempering is done at a lower temperature like 120 to 180 degrees centigrade. So this is the sequence you can see: carburizing, oil quenching, tempering, rapid austenitization, oil quenching, and finally final tempering. So now I'll give a question. You have to think of that. You have to search how to get the answer also. Instead of carbon steel, if we are dealing with a alloy steel and we want to do carburization, so how we can obtain the same, that maximum case hardness with very fine grained case and co. The hint I can give you is, in case of alloy steels, basically we understand the ms temperature and mf temperature go down. Sometimes it's go down below the room temperature. Thank you.